Hi everybody, welcome back to Insight. So if you have ever 3D printed, you know how much fun it is. 3D printing is a great hobby. It's a lot of fun to do. And if you aren't into it yet, I highly recommend that you try it out. But there is one thing about 3D printing that is really an issue for a lot of newcomers to the hobby. And that is bed leveling the printer. And bed leveling is absolutely essential. To properly level your bed is really the key to getting a successful print. Unfortunately, leveling the bed is difficult, especially in inexpensive 3D printers, because you have to level the bed by using wheels underneath the bed, and if you're new to it, it's really quite stressful and there's a good chance that you may do something wrong. However, if you want to level your bed an easier way, there is a way to do it, and that is by using mesh bed leveling. Mesh bed leveling is built into the Marlin software, and it's inexpensive and it's fairly easy to use, and it's as automatic as you can get without going out and buying a automatic bed leveler such as the BL Touch. So in this video, I'm going to show you how to set up manual mesh bed leveling with the Bigtreetech SKR Mini E3 version 2. So this presupposes that you've installed a new motherboard on your printer and that this motherboard is the Mini E3 version 2. You can use other motherboards. The only thing that they have to have is the ability to update the firmware. So if you're interested in seeing how to do this, stay tuned and I'll be right back. Welcome back. In order to activate the mesh bed leveling on your printer, you will need three things. Number one, you'll need to install Visual Studio Code on your computer. Number two, once you've got Visual Studio Code installed, you will need to install the Platform IO plugin into Visual Studio Code. And number three, you'll need the ability to update the firmware on your 3D printer. So, as I mentioned earlier, in my case, I replaced the 8-bit motherboard on my Ender 3 with the SKR Mini E3 version 2, which allows for easy updates of the firmware. Now, if you haven't done this yet, and you've got an Ender 3 or an Ender 3 Pro, I highly recommend investing in this board, as it'll essentially take your printer to the next level with a 32-bit board. And as a bonus, it'll also make your printer almost completely silent, given that it's got silent stepper drivers built in. So let's get to the computer and I'll show you how to install Visual Studio Code and all the other necessary things that you'll need to do in order to enable the manual mesh bed leveling component of the Marlin software. So let's go. Before we get into the mechanics of how to enable mesh leveling, I need to give you a quick explanation on the differences between regular bed leveling and mesh bed leveling. So typically, inexpensive 3D printers come with simple knobs under the print bed that adjust the bed up and down by turning the knobs. The Ender 3 comes with 4 knobs, one on each corner of the bed. Turning each of the knobs to the right or left will either raise or lower the print bed. The goal of this system is to achieve the proper Z offset between the bed and the print nozzle. The Z offset is the distance between the nozzle and the bed. Typically, the right offset is measured by a piece of paper, so the distance between the nozzle and the bed should be the height of a typical piece of paper. Theoretically, all four sides of the bed should be a uniform distance from the print nozzle. If you're lucky, your print bed is absolutely flat, and so the Z offset is uniform across the entire print bed. But what happens if the print bed is warped, as is often the case with 3D printers? If this is the case, no matter how well you level the bed using the knobs, certain parts of the bed are not going to be properly leveled. And this is where manual mesh bed leveling comes in. When you enable mesh bed leveling, you can create a mesh model of your bed, lowering or raising the nozzle while printing the first layer to accommodate for the uneven spots. In other words, the printer remembers the mesh and in this way deals with a warped bed. Okay, so let's enable mesh bed leveling. Alright, you'll need to download and install a number of applications. The first thing you'll need is the Visual Studio Code software installed on your computer, and then you'll need to install the Platform IO into Visual Studio Code. So go to the Visual Studio Code website and download the application. You've got a choice between Windows, Linux, and Mac. I'm going to assume most people are going to be using Windows. I am using Windows. So click on that and download the application. When it is downloaded, go to it and install it on your computer. Simply click on the software, and when the installation window comes up, accept all the relevant information. You might want to create a desktop icon. I usually like to do that. Click on next and then install. The next thing that you'll need to do is go to the Bigtreetech GitHub page and download the firmware folder here, Bigtreetech SKR Mini E3 link, and just download the code zip. Click on download. And then once it downloads on your computer, move it to a folder of its own. I'm going to put it in the SKR Mini firmware. So it's just an empty folder, and extract it from the folder. All right. So once you've got everything downloaded and installed, open Visual Studio Code, and we're going to have to navigate to the folder with the configuration H file in the firmware folder from SKR. So the way we do this is by opening up Visual Studio Code. Now, one thing that you'll need to do once it's opened up is to install Platform IO, because otherwise you will not be able to compile the new firmware. The way you do this is by installing the Firmware IO extension. This is the extension icon. Click on that, and here just type in Platform IO, and there it is. So install that extension into Visual Studio Code. I've already got it installed, so I'm not going to do it again. Once it's installed, you'll need to open the file that we downloaded from SKR, from the Bigtreetech GitHub page. So go to Open Folder and navigate to the SKR Mini folder, or wherever it is that you put the download. So I put it into SKR Mini Firmware. Here's the folder. Click on it, click on Firmware, go to whatever version of board that you're installing the mesh bed leveling into. Click on, I'm going to go to version 2 because that's what I have, and then highlight Marlin 2.0.7.2 SKR Mini E3 version 2 and select the folder. It'll take a minute to load. Once it loads, click on Marlin. The file that we will need to make the changes in is the configuration H file. There are a couple of things that you'll need to change. Before we change anything, however, I recommend that you give the new firmware that you're going to compile a distinct name. I'm just going to call it my YouTube channel name, Insight. And since I am using the Ender 3, I will just leave the Ender 3 there as the name of the printer that I'm using. The next thing that you want to do is put a new name for the machine. So this is what you'll see on the LCD display of your SKR Mini E3. I'm again going to put the name of my YouTube channel. Okay, now we're going to change some of the commands that will enable the mesh bed leveling tool. The way I would recommend doing this is by going to the Find option and opening up the Find field. So you're going to have to change a number of different functions, and the first one is going to be probe manually. And you're going to have to remove the 2 slashes in order to enable it. Then you're going to go to nozzle to probe, and you're going to have to change the numbers here to 0, 0, and 0. So we're going to start basically at the home point. You're going to have to go to mesh bed leveling next, and you're going to again remove the 2 slashes in order to enable it. You're going to go to restore leveling after G28 right here and uncomment this. The reason you need to enable this is because mesh bed leveling is automatically disabled after a G28 command is initiated. So in order to avoid that from happening, just enable this command and it will restore mesh bed leveling after any G28 command is initiated. Next, go to grid max points, which is right here, mesh bed leveling. And you want to set the number of points on the bed that will be scanned to create the mesh. By default, it's 3. So it's going to be 3 times 3 or 9. I like to have 5. It's going to take more time to set it, but it's going to give you a higher resolution mesh on the bed. And finally, you need to enable LCD bed leveling. Right here. Define LCD bed leveling, uncomment that, and this will give you the option to level your bed on your printer's LCD. So those are all the things that you need to change in the configuration H file. At this point, you're going to compile a new firmware bin file, and you do this by clicking on the Platform IO build check mark. And this will build the firmware bin that you'll be able to take to your printer. So let's click on that, and if we did everything correctly, we will get a message saying that the new firmware has been built and that it's been successful. If you get an error, it means that somewhere along the line you either changed something that you shouldn't have, or that there's some sort of a conflict. You need to go back and figure out where the error is. But in our case, we do not have an error. We have successfully built a firmware bin file that we can flash our printer with. And we will find this bin file if we go to the folder that we downloaded from BQ, Bigtreetech. We go to firmware, version 2, Marlin, and the firmware file will be put into the .pio folder and build. And we can see that the firmware file is here. Because if you take a look at the time, it's 12:31, and on my clock it says 12:33. So yes, it was built 2 minutes ago. So this is the file that we're going to be using on the printer. So the next thing that you'll need to do is move the file onto an SD card, which I've got right here, and it's ready to go. So I've already got a firmware bin file here, which I'm going to delete, and I'm going to replace it with this new one that I just made. And at this point, you take the SD card out of the computer and you are ready to install the new firmware on your printer. So here it is. I'm going to take this SD card and we're going to install the new firmware on the printer, and then I'll take you to the next step of how to actually use the manual mesh bed leveling. So let's put the SD card into the printer, turn off the power, and flash the printer with the firmware that I just created. With the SKR board that I've installed, updating the firmware is automatic when you have a firmware bin file on the SD card and you turn on the printer. When updating, the printer's screen will be blank for a couple of seconds, and then you'll see the new firmware that's been flashed. Let's check on it by going to motion to see if bed leveling is there, and it is. So let's level the bed using this new function. But before we do anything, we'll need to increase the bed temperature to whatever it is that we usually print at. In my case, it's 60 degrees. Now, one thing I do recommend is that you do a regular bed leveling using the wheels first and then move on to doing a mesh bed leveling of the printer. The reason for this is that the wheels-based leveling is great as an overall macro-style bed leveling, whereas the mesh bed leveling is much more granular and fine-tunes how the printer interacts with the print bed. So leveling the bed with the wheels is a good foundation for mesh bed leveling, and I would definitely begin with that. Once you're done leveling the bed using the wheels, move on to the mesh bed leveling. So go to Motion, Bed Leveling, and enter. The printer will go to the home point, and then you'll click to begin the mesh bed leveling process. Move the extruder nozzle up and down by using the knob on the LCD screen. Turning the wheel to the right moves up the nozzle. Turning it to the left moves it down. Use a piece of paper to gauge the Z offset. You want to feel that there is a slight pull on the paper, but you want to be able to move the paper. After a while, you'll get a sense of what feels just right. So move from point to point by clicking the knob and calibrate each of the points on your bed. When you're done creating the mesh, you need to be sure to set the fade height. The fade height basically tells the printer when to stop using the mesh. This is important as you want your layers to be straight. If you leave the mesh throughout the print, you risk making the layers uneven. When everything is done, be sure to store your settings to eeprom. Otherwise, you'll lose your mesh configuration. The final step is to test how level the bed is by printing out a quick bed level test. There are many of them available. The one that I chose is made by P. Greenland and can be found on Thingiverse. It's a very short print and shouldn't take more than 10 minutes. What you need to pay attention to is the squish on each of the squares. They should all be consistent and there should be no gaps between the print lines. One final thing that you need to know is that you'll need to load the data on your eeprom every time you turn on your printer. You can either do this on your printer's LCD, or if you have Octoprint installed, you can do it from the Octoprint terminal. If you enter the G29S0 command, it'll tell you if your mesh bed leveling is on. This command will also give you all the values that you've entered on your mesh. The M420S1 command will turn on mesh bed leveling with the settings stored on your eeprom. Finally, on the latest pre-configured firmware bin file on the Bigtreetech Github page for the SKR Mini E3 version 2, mesh bed leveling has been turned on by default. So if you don't want to configure and compile your own firmware bin file, you can just download this one and install it on your printer. But if you want anything special, for example, more points on your mesh, or perhaps your name to run across the bottom of the LCD screen, you'll need to compile your own firmware bin file, which in my opinion is a good thing to know how to do. So that's it for this video. If you found it of value and would like to see more videos, it would help me very much if you hit the subscribe button and the notification bell. Until next time, take care, and I'll see you soon. Bye-bye.